All right, our task is to figure out how to get these circles to actually map to the surface itself. The good thing is this surface actually is planar. Even though it's vertical, it is planar. So all we have to do is get the circles to sit flush with the surface, and then we can trim them out to create a perforation. Basically, the one thing that we're missing here is what's called a normal. It's very important that you guys know that term. If you're keeping notes or anything like that, write down the term normal. Okay, a surface normal is the perpendicular angle to tangent of any surface. So, I don't have any cool diagrams that... Let me just do it this way. I don't have any cool diagrams preloaded, but basically these are essentially, this is a great one. Or something like this, or something like that. So a surface normal is the perpendicular angle from the tangent plane or tangent line axis of any surface or curve. Well, surface, yeah, surface normal. Yeah, so what we've got to do is find a way to find the normal of this surface, and then orient our circles to match the normal. Okay, and right now it's really simple because we could do it for all of them at once. But later on, when we have a warped surface, we don't just find one normal, we have to find many normals. Tens, hundreds, even thousands of surface normals to map geometry onto. Okay, so that's just a precursor. But anyway, the surface normal, we can actually map a circle directly to a normal by using circle CNR. And I'll put it here as our goal point. Let me move this down so we have more space. Curve primitive. Circle CNR obviously is going to require a center point. It will require the normal, which is measured as a vector, and it will require the radius. So the center point and the radius really aren't that different. The normal is. So what we're going to do here, there are a couple other ways of doing this too. The reason I lead you directly to normal is because it's the most universal. So let's get rid of this circle. And so here's what we're going to do. The points obviously are going to stay the same. So that's good. Now our circle is mapped to all the points. Our radius will change later as needed, but the normal is found by analyzing the surface. So here's what's key. Under surface analysis, this is another pair. It's very, very important to know that these two go together very often for our class. I'm giving you a lot of upfront knowledge here. I don't expect you to remember these and memorize them after you leave here today, okay? Just know that. These two are a pair, just like the other two are a pair. You're going to need surface closest point and evaluate surface. So I'll drop in evaluate surface. This is under surface analysis. And I'll do surface closest point. Okay. So I'm going to put closest point in front of evaluate surface. And here's why. What these two do is it finds a point on a surface, which is important, and then it will evaluate the surface properties at the UV coordinate level. So that means if a surface is warped, it measures any of the UV points' orientations. So it'll take whatever that point is and it'll find what the plane, the tangent plane is, and it will output your normal. So that's what this is right here. You've got your point, your normal, and your frame. Your frame being the tangent plane. So I'm going to piece all of this together for you and then I'll re-narrate what it means. Okay, so this is another triangle that we're going to need to do. So obviously our surface is going to be important. Let me turn that back on so you can see which one. That's our original surface. The UVP output of closest point is going to connect to the UV of evaluate surface. And that's because you're going to evaluate that point on the surface. You're going to evaluate its UV properties. So our connection pieces are the surface gets plugged obviously into evaluate surface, but it also gets plugged into the surface of surface closest point. I'm sorry, we want a point. My mistake. So let me step back. The surface gets plugged into evaluate surface. The surface closest point, we need to map a point to test and the surface to test. So the surface obviously is going to be this. There's your little triangle. But you also have to find, usually it's the centroid, or it could just be any point on that surface, really, since it's all flat. But for best practice, I use the centroid. And that's found by under surface analysis area. And this part's really counterintuitive, but area will receive a geometry, measure the area numerically, and give you the centroid of that geometry. You wouldn't know it was there unless I told you. Yeah. So surface gets plugged in. You can see the area gets calculated, 502 and something for me. And then the centroid is an XYZ value, which I can plug into surface closest point. Now they're all gray. I'm going to, hold on a sec, G. Analysis. Okay, so all of these are analysis nodes, components. They analyze a surface. So I'm going to label this as find surface normal. And through a process of hiding certain things, I'm also going to hide my deconstruct brep. I'm going to hide my points. And here's what I want you to see. We have the evaluate surface. You can't see it because it's green really very well. But evaluate surface has assigned an X, a Y, and a Z axis to this. Notice how now there's a plane. And on that plane, there's a red axis, which is the X, a green axis, which is the Y, and an unknown, undisplayed Z axis, which is your surface normal. Does that make sense?
Yeah.
Okay. So quickly, I'm going to plug the normal in and then recap what just happened. So the normal output is the N, and that gets plugged into the normal input of circle CNR. And now your circles are properly mapped in the same orientation as the surface itself. So, as a recap, guys, all we did was swap this out for circle CNR instead of circle. And then these three components were added exclusively to find the original surface normal. That's it. There's a long explanation, but those three components, all they do in this case is find the surface normal. So what I'm going to do here is pause. Well, I'll stop the video, but I'll wait for you all to get this correct, and then we'll move on to the last little bit where we can actually perforate the surface.